Today, psychology and its methods are recognized as scientific. Like any other science, experimental psychology uses scientific methods to gather data and perform research. The development of those methods, however, had to overcome the same obstacles as any other scientific endeavor. For any science, one of the biggest obstacles we have to overcome is our own minds. While it might be tricky to ask this question of our student population, I'll ask it anyway. How many of you have been unpleasantly surprised by your grade when you've received a test back? Like, you were sure you'd earned at least a B and probably an A. Why did you get a C? Or worse, why did you fail? Now ask yourself, why were you unpleasantly surprised? Well, that's a hard question to answer, right? I mean, you may have thought to yourself, but I knew every answer as I worked through each question. I didn't struggle at all when I worked through those problems. I know all of this stuff. The reason we sometimes walk out of a test thinking we've aced it when we hadn't is a little something called overconfidence bias. This bias is the human tendency to hold a misleading or outright false assessment of our own talents, skills, or knowledge. It is, in other words, our human tendency to be more confident in ourselves than we are correct in our abilities. Overconfidence bias is the reason why you felt so confident walking out of that test, certain that you'd done well. Bottom line, you didn't know how much you didn't know. If it makes you feel better, you should know that all humans are subject to overconfidence bias. Just take a quick look at these statements. In 1895, Lord Kelvin, the famous British physicist, confidently declared that, quote, heavier than air flying machines are impossible. In 1957, the inventor of the vacuum tube, Lee De Forest, claimed that, quote, man will never reach the moon, regardless of all future scientific advances. And in 1977, Ken Olsen, president of Digital Equipment Corporation, which was the preeminent computer company in the US at the time, said that, quote, there's no reason for anyone to have a computer in their home. So as you can see, even highly educated people have made what are, in hindsight, ridiculous statements about what is possible. So, how do we avoid, as much as we can, biases like these when doing research? The best way a psychologist or anyone can try to sidestep the various biases that hamper human thinking is by adopting what's often referred to as the scientific attitude. Really, this attitude is a set of traits that critical thinkers tend to have. There are 7 of these traits. Now, critical thinkers are open-minded. They can live with uncertainty and ambiguity. They enjoy mysteries. They avoid easy compartmentalizations of the world, and they resist black and white analyses of complex issues. Now, critical thinkers are also able to identify their inherent biases and assumptions. They know that people's beliefs and experiences shape the way that they view and interpret their worlds. Critical thinkers practice an attitude of skepticism. They've trained themselves to question the statements and claims of even those people they respect. They are ready to re-examine their own ideas when new information pops up. Critical thinkers distinguish facts from opinions. They recognize the need to rely on scientific evidence rather than personal experience. And yet, critical thinkers don't simplify. They realize the world is complex and there may be multiple causes for behaviors. Critical thinkers use the processes of logical inference. They carefully examine the information they're given, and they learn to recognize inconsistencies in statements and conclusions. And finally, critical thinkers review all the available evidence before reaching a conclusion. They will consult diverse sources of information, and they'll consider a variety of positions before making a judgment. And again, if new information pops up, they're willing to go back to their old conclusions and revisit them if needed. One of the broad parameters that psychologists use to gather data is through observational studies, through which researchers observe human or animal behaviors. The narrowest kind of observational study is the case study, which allows psychologists to study one individual subject in great depth. The ultimate goal of a case study is to discover some truths that might generalize to the population as a whole. A researcher might spend years observing and interviewing the subject of their case study. Most usually, case studies are used as a way to better understand certain diagnoses, such as that of autism, in clinical psychology. Unlike a case study, most observational studies focus on groups of people or animals. In order to ensure that an observational study can be generalized to the larger population, the researcher has to consider the focus of their study very carefully. They must determine who the population they want to study is. Who is this group of people about whom they want to discover information? Is that population Americans? Is it American teenagers? Or is it really just American teenagers who attend public high schools? Of course, unless your target population is extremely small, it's very unlikely that a researcher would be able to study every single member of that population. So, in order to move ahead with their research, psychologists instead focus on a sample representation of that target population. The best way to determine this sample representation is through random sampling. The researchers try to include as many people in the target population as possible through randomly picking from a list of possible participants from that population. By randomly selecting the participants for the sample, researchers ensure that all members of the target population have an equal chance of participating in the study as a whole. By focusing research on the sample population, researchers can then hopefully make inferences about the general target population of the study. One kind of observational study in which accuracy depends both on the use of random sampling and on other important items is the survey. Surveys are one of the most used methods of research in psychology. They require the subjects of the study, the respondents, to self-report a response. Surveys are relatively easy to conduct, especially in the modern day with websites and social media options. However, the survey as a method is one that's fraught with missteps. One big one, the wording effect, when the way a question is phrased interferes with the results of a survey. Here's an historical example of how the wording effect can alter the results of a survey. The conclusions of a 1992 survey found that 1 in 5 Americans doubted that the Holocaust had occurred, and that another 12% said they weren't sure. Let me repeat that. A survey in 1992 found that 20% of Americans doubted the Holocaust, a verified event with copious documentary, photographic, and video evidence, had occurred. Another 12% weren't sure that it had occurred. So 32% of Americans, 1/3 of Americans, weren't sure what to make of the Holocaust. Well, that's ridiculous, right? So first, you should know that this was a telephone survey. Respondents were cold called on their landlines, which were a thing back then, and were asked this question. They didn't read it for themselves, they were asked over the phone. So let's look at the way the survey question was phrased. It reads, as you know, the term Holocaust usually refers to the killing of millions of Jews in Nazi death camps during World War II. Does it seem possible or does it seem impossible to you that the Nazi extermination of the Jews never happened? So this phrasing is a problem, right? Even just reading it aloud to yourself is confusing. What do they mean Holocaust usually refers to the killing of millions of Jews? And frankly, after hearing, does it seem possible or does it seem impossible, I'm already not listening to the rest of the question. I'm trying to figure out what it is they want me to think. So this survey might make you feel better. That same year, 1992, another poll about the Holocaust was done by Gallup. This one was phrased much more simply. Do you doubt that the Holocaust happened or not? Unsurprisingly, the conclusions from this poll were quite different. Only 9% of Americans said they doubted the truth of the Holocaust, while another 4% weren't sure. So, a total of about 13% of Americans were uncertain about the Holocaust, which, yes, is still way too high a number, but that's much better than thinking that a third of all Americans were Holocaust deniers. Sometimes, observational studies are conducted to see if a relationship exists between two traits. We refer to these kinds of studies as correlational studies. The correlation between two traits is illustrated mathematically with a correlation coefficient. You can see a sample correlation coefficient on the screen. The lowercase r stands for relationship. On the right-hand side of the equal sign, the positive or negative refers to the direction of the relationship, while the number refers to the strength of that relationship. Once a researcher has their data points, they often develop graphs called scatter plots, which are used to illustrate the relationship between the two traits in a correlational study. While it's incredibly rare that a correlation coefficient shows a perfect positive or negative correlation, that would be illustrated by all data points forming a signal diagonal line up, positive, or down, negative, scatter plots do often show directionality of the relationship if one exists. And you can see that here on the screen. One big problem with analyzing correlational studies is the common human misconception that identifying a correlation automatically indicates causation. But say it with me, correlation is not causation. When someone misinterprets a correlational study as a causational studies are what we call experiments, whole institutions can take steps to address a problem that might not exist. Here's an example. In the 1980s, a study was published that showed a correlation between poor ocular motor skills, poor eye movement, and poor reading skills in children. Education policymakers jumped all over that finding, and whole protocols were established to help children who were identified as poor readers train their eyes to move better. These kids were asked to wear plastic frames, and then they were told they had to keep their eye movement within the visible arcs of the frames as they read. Or they were shown a few lines of highlighted text on a computer and were told to focus only on those lines of text. After completing these protocols, the children were tested again, and their reading didn't improve. Oops. Now, those who jumped on this study thinking it proved causation had a problem of directionality. Not understanding, or worse, not caring, that correlation is not causation, they assumed that variable x, poor eye movement, caused variable y, poor reading. Subsequent experiments concluded that, in fact, a child's poor reading ability was what caused their poor, seemingly uncontrollable eye movement. Kids were mostly anxious about their reading skills, and their eye movement was a manifestation of that anxiety. In order to prove causation, researchers must conduct an experiment. More on that in a bit. Observational studies, such as surveys, can also be used for longer-term or comparative research. Longitudinal studies return to the original studied group at various times over a predetermined period. For instance, researchers might first study a group of children aged 7 and then return to study them at 10-year increments for the next 30 years. At each point, the same sample population is used. Such a study might include personal face-to-face interviews, but often researchers use surveys and study other information about the subjects. They can look at school grades or measures such as height and weight to draw conclusions. Now, for instance, since 9/11, researchers have tracked the development of PTSD among sample populations across the country to see how soon, if ever, PTSD manifests itself. Cross-sectional studies, in contrast, are comparative. Researchers study several sample populations at the same point in time. This type of study provides a snapshot of society. The most common cross-sectional studies in many countries are based on attitude surveys. In the United States, for instance, researchers have tracked how support for same-sex marriage has changed over time across many different age groups. Such studies consistently demonstrate that younger age groups are more likely to support same-sex marriage at any given point in time. But over time, they also demonstrate that in general, support for same-sex marriage has increased. Observational studies can often lead to experimental research. When a correlational study shows a strong positive or negative correlation, then researchers will often conduct an experiment to determine if the strong correlation might, in fact, determine causation. In our popular American culture, we often connect the word experiment specifically with a laboratory setting. But in reality, experiments can occur in any number of environments. What differentiates an experiment from an observational study is the conditions under which research is performed. In an experiment, the researcher focuses on cause and effect by manipulating variables while controlling other factors. Today, psychology researchers are bound by ethical rules such as informed consent when conducting experiments on humans. The specific principles for that are noted in your assigned readings. It shouldn't surprise you that psychology's earliest experiments on humans and animals often didn't abide by what our 21st century society would call ethical behavior, and often crossed the lines regarding their contemporary ethical norms as well. We'll learn about some of those experiments as we work through this introductory course in psychology. For now, though, let's look at one specific questionable experiment from the early 20th century, and let's break down the basic parts of an experiment as we learn about Dr. Goldberger's research on pellagra. In 1906, an epidemic of pellagra affected many poor, mostly rural Americans living in the South. Colloquially known as the sharecropper's plague, pellagra caused vomiting, diarrhea, and dermatitis, skin lesions. Untreated, pellagra could cause dementia and eventually death. Some years of the epidemic, which ran until the 1940s, saw a 40% death rate in some southern states. Most southern doctors believed that the disease was caused by poor sanitary conditions, since most, but not all, Americans diagnosed with pellagra lived in areas with poor or no plumbing or sewage infrastructure. There was some racial prejudice associated with this disease as well. Many of those affected were black sharecroppers, and unfortunately, in the Jim Crow era, many white Americans erroneously believed that black Americans were less sanitary than white Americans. Doctors prescribed topical ointments to treat the dermatitis, and they urged their poor and often uneducated patients to clean their homes more often. These treatments, however, were not curing the disease. And not everyone agreed that the cause was poor living conditions. After all, if that was the cause, then why weren't more city dwellers affected? Dr. Joseph Goldberger, a physician with the Surgeon General's office, believed that the correlation between poor plumbing and a pellagra diagnosis was confounded by another variable. This is a common problem with correlational studies and sometimes with experiments: the existence of an unknown and/or unaccounted for third or confounding variable that might actually account for the correlation or the causation. Dr. Goldberger believed that it likely wasn't poor living conditions that caused pellagra, but rather an inadequate and unbalanced diet which caused the illness. The poor people so often diagnosed with pellagra ate a diet overwhelmingly dependent on corn. In 1914 and 1915, he conducted a series of experiments after which he concluded that poor diet was the cause of pellagra. His first experiment was at an orphanage, and he treated the entire population of children to a more balanced diet. Not one of the children developed pellagra, despite unpleasant living conditions. The second experiment, conducted over 2 years, used inmates from a Georgia mental hospital. These patients were separated into 2 groups: an experimental or test group which received a more balanced diet, and a control group, a group whose conditions remained unchanged. They received the regular diet. The men in the balanced diet group recovered from or never developed pellagra, while the men in the other group continued to develop pellagra. However, some doctors were still not convinced by these findings, so in 1916, Dr. Goldberger conducted another experiment to explicitly disprove the prevailing idea that poor sanitation caused pellagra. What Goldberger wanted to disprove was that poor living conditions was the cause of pellagra. His hypothesis for this experiment was, like all hypotheses, essentially a simple if-then statement. Even if a person mimics the poor living conditions of a typical pellagra sufferer, they will not be diagnosed with pellagra. Now, since any experiment involves manipulating variables while holding other factors constant, we need to understand precisely which variables were manipulated in Dr. Goldberger's experiment in order to understand it. First, I want to be very clear. Dr. Goldberger's experiment was not ethical by modern standards, and you'll see why in a little bit. Well, first, he had to operationally define the variables in his hypothesis, and thus further refine it. An operational definition for Goldberger's original hypothesis would have to clearly describe what he meant by, quote, mimics the poor living conditions. So here's where it gets kind of gross. Goldberger decided to mimic these living conditions by developing a twofold procedure. First, he decided to inject his test subjects with the blood of a pellagra victim. And second, he decided that he'd feed his test subjects pills made from the dried scabs and excrement of pellagra victims. I'll let you just take that in. This cocktail, taking the blood injections and the pills, is the independent variable in Goldberger's experiment, because that is the variable that is manipulated independently of any other variables, such as the height, weight, gender, or actual living conditions of his test subjects. The dependent variable of his hypothesis, the variable that will change depending on the effect of the independent variable, is the pellagra diagnosis. Dr. Goldberger, in another move considered unethical today, didn't bother to randomly sample or randomly assign individuals to experimental and control groups. Instead, he used 16 volunteers, including himself, his wife, and a lab assistant, as test subjects. That's right, Dr. Goldberger injected himself and his wife and other colleagues with the infected blood, and then they ingested the pills. They continued this experiment over 7 trials. While some of the test subjects developed diarrhea or experienced some nausea, not a surprise, none of them developed the other symptoms of pellagra, so none were ever diagnosed with the disease. Unfortunately, even this experiment didn't silence all critics. Dr. Goldberger even replicated his original experiments using balanced diets as the independent variable with groups of Mississippi prisoners. These prisoners were granted pardons in exchange for participating in the experiment. He needed to replicate his original findings because replication is an important step in any experiment. If the original experiment cannot be replicated, then the conclusions of that experiment can't be trusted. For some doctors, even that replication didn't matter. They preferred to believe what they always had. This refusal to change one's mind, even in the face of overwhelming evidence to the contrary, is referred to as cognitive dissonance. We'll study that concept later in the course. It wasn't until 1937, when a different researcher proved that pellagra was caused by a niacin, vitamin B3 deficiency, that treatment began to change in the American South. The field of psychology employs multiple methods of research, and these methods have helped to further define and shape our modern understanding of this discipline. As we continue further in the course, we'll examine some of these more famous studies and experiments, some of them ethical, many of them not, by today's standards, as a way to delve more deeply into our study of psychology.